Hi, we are Team MC Squared. Our number is 53098, and this presentation will cover our robot code, design, and strategy. This is our team, including mentors from Team Spider. We also virtually mentored a younger 4th grade team called the Lego Leopards.
Our whole team was able to work together with the robot for additional bonus in team building skills. We set up a meal schedule so that everyone could work together throughout the challenges and enjoy time together. Although team members were able to choose their primary focus throughout each meeting, everyone was active with the project and robot. We used a variety of in-person and digital platforms for our team to communicate and plan together. We had the most fun using Discord since we were able to talk and send pictures to each other.
We used something called the risk-reward process intentionally to determine what missions would be worth completing. We ranked every mission by its difficulty and its points reward. The risk versus reward system helped us with the decision to start with the easier missions with high rewards. When we had time, we added the harder missions.
This chart is used to organize the missions we have done and see how many points we have gotten. It was fun to see the number of points scored go up and up as our team coded more and more. We ultimately reached a max of 530 points. We get these points without even doing anything. Our top priority for this run was having our robot navigate accurately and precisely to avoid losing precision tokens.
Our Run 1 strategy is to get quick, easy points on the board. This run solves 5 missions. We utilized a single drop on modules with a high torque arm to solve both the switch, the engine to electric, and then retrieve the cargo from the plane. We also wrote down pseudocode similar to this for every mission run we did. This helped us make easy changes and work out the robot schematics before spending the extra time coding everything up. This is our strategy for run 2. While we used precise line following to get our robot around the chicken for the qualifying tournament, our new module drives right through the chicken and still manages to leave it in the circle. The tape used to help our alignment when we had a forklift module for the qualifying tournament, but we now have a simpler lever catch system in place with our new module.
This is the longest and most risky run. In run 3, we wanted to make sure that we get as many missions done as possible before ending at accidental avoidance. Our robot consistently uses the color sensors to track where it is located on the table and align it off of walls, lines, and mission structures.
We used the waterfall process for the robot build and spiral development for the software. Before building the robot, we evaluated game rules and mission requirements and documented 18 requirements we wanted our robot to meet.
These are our robots Tanjiro and Simp. We kept both robots in matching configuration, which allowed us to send robots home with team members and work in parallel. We used LEGO Studio CAD to design different robot ideas so team members who didn't have access to all the LEGOs could try out ideas. The final robot design instructions from the CAD were used to keep the robots in exact configuration. Module design for Run 1 was originally a high-torque version of our Run 3 module. The team adapted it to solve new missions. This is our Run 2 module. The team had a challenge with the large cargo falling off the module and came up with an innovative solution using rubber Lego parts to better grab the module. We also used a passive dropper which used the mission doorstep to trigger the package to fall, ensuring it was always in the correct position.
The forklift module you just saw for Run 2 was pretty much scrapped after the qualifying tournament. Exploring on YouTube, we found a video that showed us how to utilize a truck module for carrying both units at once.
Our module for Run 3 is our most complex. It uses 2 motors to control arms on 3 sides of the robot and solves 9 missions.
Our team decided to learn Python and challenge ourselves with the new code language. We've learned from the team Failure Architects that Pybricks has built-in libraries which allow for soft start and stop, which allow for more precise navigation. We also tried to learn the configuration management tool GitHub. This tool had professional features for software development, but learning both Python and GitHub fully was beyond what we had time for. We stuck to emailing the code until we can get more time to learn this tool.
We coded up many functions in Python that we could call and use over and over for rapid programming of bot runs. Organizing our code into reusable functions made programming things for line follow easier. We kept key variables like speed and critical gain as inputs to the functions. Here are some example codes. By using comments and clear function names, the code is easy to understand and follow. This helped maintain the code and troubleshoot. We found a PID tutorial online and learned to write efficient, proportional, integral, derivative feedback code. We used this code to fix unreliable motor steering by correcting navigation to work with the color sensors to improve line following.
Because Pybrick is still in beta release, we had to program our own bootloaders to manage the robot run. All you have to do is select the run number and hit enter to run each program. The display shows when the robot is running and when it is done. Documenting our robot runs 3 charts allowed us to look back and see where the robot had any glaring inconsistencies with alignment. Even after changing the mission order on this run, our placements were still very reliable. A big innovation for the team was raising the color sensors so they could get a smoother input to the PID line following code.
Our run accuracy improved once we built an alignment fixture so we could launch from the same spot every time. This slide shows our drop-in module design started and ended. This was a tricky Lego part to build, to make sure the module would drop on the robot quickly each time without directly attaching. This pattern was evolved and tested many times before it was then used for all other mission modules.
Thank you.